On our notes, we want to go to our limits note sheet that we started with or we're working on yesterday. And if you recall, yesterday we had all of these limits going to infinity and negative infinity, and the stuff we just talked about on the Kahoot with the top heavy, bottom heavy or equal. And so today we are going to talk about limits with E. So I want to remind you guys, hopefully you remember what the function y equals e to the x looks like. Do you? We'll see here. Y equals e to the x. Remember, that's an exponential function. And if you can remember what this looks like, in fact, all exponential functions have the same basic graph. If you can remember what e to the x looks like, you can do these limits fairly easily, the ones to infinity and negative infinity. Because remember, all exponential functions have this J shape. And so if we want to find the limits of that function, let's say we want to find first the limit as x approaches infinity of e to the x. And then we will also find the limit as x approaches negative infinity of e to the x. Well, let's just think about what that means graphically. The limit as x approaches infinity, that means the graph going to the right. What happens to the graph of e to the x as it goes off to the right? Well, as the graph goes off to the right, it keeps going up and up and up and up and up to infinity. And so that answer is positive infinity. So the limit as x goes to infinity of e to the x is equal to infinity. Okay, and again, that's because as this means going to the right, as the graph is going to the right, the outputs are getting bigger and bigger. This means going to the left, all the way to the left. Well, if we notice graphically, as we're going to the left on this graph, that one has a horizontal asymptote at 0. So that limit as x goes to negative infinity of e to the x means what happens going to the left, it's going towards 0. So that answer is going to be 0. All right, before I move on, does anybody have any questions on that? No? All right. Then let me give you a different polynomial. Okay, so e to the x is an exponential function. But and we did some rational ones, that's what we were just talking about. But let's say we wanted to find the limit as x goes to infinity of x to the 5th minus 2x squared. Okay, we're going to find that limit, and then let's do it to negative infinity also. The limit as x goes to negative infinity of x to the 5th minus 2x squared. All right, so we're finding the limit as x goes to infinity of x to the 5th minus 2x squared, and the limit as x goes to negative infinity of x to the 5th minus 2x squared. Well, it's not rational. We're not doing the top heavy, bottom heavy equal thing. It's not e to the x, which, we know to the right goes up and to the left goes to 0. But these, we only have to worry about the highest exponent, because what happens is as x becomes extreme, this takes over the function. So I'm only concerned about the x to the 5th. This part really becomes irrelevant as x becomes extreme. And so all I have to do is figure out what's happening at x to the 5th as my x values get larger and larger and larger. Well, if my x values are huge positive numbers, like 1 billion, and I take 1 billion to the 5th power, well, that would be a really massively big number, but it would be positive is the key. It would go to positive infinity, because it's just going to continue to grow and grow. Okay, and so it went to positive infinity. Now, if I did the second one, I'm plugging in negative 1 billion. Well, again, I'm only concerned about the x to the fifth. And if I did negative 1 billion to the fifth power, that's a negative times a negative times a negative times a negative times a negative. It's going to be a massive number, but I know it's going to be negative massive number, which is negative 1 billion. So for those polynomials, we're just looking at the highest exponents. All right, let's combine a couple here. So I'm going to do two more examples, then have you guys do some. So the limit as x goes to infinity of e to the x divided by x cubed minus 2x. And let's find the limit as x goes to negative infinity also. E to the x over x cubed minus 2x. All right, so let's consider this. For the first one, we're plugging in a billion, a large positive number. Well, I know that e to the x goes to infinity. And in fact, e to the x is stronger than x to the third. When I say stronger, e to the x is like the heavyweight champion of functions. It is stronger than all those other polynomial functions. Those exponential functions grow so quickly. And so what happens in this case is, because we're plugging in a large number, we know that e to the x goes to infinity, and that's so much stronger than the bottom. If you take a large number and divide it by something smaller, it continues to grow and grow and grow. And so that will go to positive infinity. Now looking at the second part as x goes to negative infinity, let's deal with e to the x first, because if I'm plugging negative infinity into e to the x, well, remember when we started way back here? And we said that as e to the x goes to the left, it goes to 0. That means that the top of this goes to 0. And so I don't care what happens to the bottom as long as it's not 0. And it's not. I don't care what happens to the bottom, because 0 divided by anything is going to be 0. And therefore that limit is equal to 0 because the top goes to 0. All right, so any questions on those last four? All right, let's go over this class kick together then. So to do the first one, this is a polynomial. So I'm finding the limit as x goes to infinity. I only care about the largest exponent. I only care about this. And if I plug in a positive number squared is a positive number. And so that will go to infinity. Okay. For problem 2, I'm plugging in a large negative number, so like negative 1 billion. And I'm only concerned about the largest exponent. So negative 1 billion squared, a negative times a negative will be positive. So that will go to positive infinity also. For problem number 3, I'm plugging in a positive number. I'm only concerned about the x to the third. I don't care about any of the other stuff. So a billion cubed is a really big positive number. So that will be positive infinity. And for the next one, I'm plugging in a big negative number. So if I do negative 1 billion cubed, That's negative times negative times negative. That's going to be a really big negative number, or negative infinity. Any questions about the first four? All right, for problem 5. So I'm visualizing that e to the x looks like this. And so I know as the graph goes to the right, e to the x goes to positive infinity. Okay, that's talking about this part of the graph. And I know as x goes to the left, e to the x goes to 0, because that's talking about this part of the graph, and that is a horizontal asymptote at 0. So when I do some then rational functions that have e to the x in it, so the limit as x goes to infinity, that means the top is going to go to infinity, and I don't care what the bottom does, it's not 0. And so if I take a huge number divided by a smaller number, that goes to infinity. And for problem 8, as x goes to negative infinity, this goes to 0. And this is not 0. Okay, so if I have 0 divided by anything, that's going to be 0. All right, any questions on those?